Welcome to arXiv Preprint Server Daily's AI Frontiers, where we explore cutting-edge advances in language AI. This episode synthesizes key research published on May 4, 2025, focusing on three critical areas: efficiency improvements in language models, fairness in algorithmic decision-making, and robustness against adversarial attacks. We'll examine insights from 19 seminal papers that are shaping the future of computational linguistics and artificial intelligence. Computational linguistics serves as the vital bridge between artificial intelligence, linguistics, and computer science. This interdisciplinary field powers essential technologies we use daily, including machine translation systems, voice assistants, and conversational chatbots. Current research focuses on overcoming significant challenges such as improving computational efficiency, reducing algorithmic bias, enhancing model interpretability, and increasing system robustness. The ultimate goal remains developing AI systems capable of human-like language understanding and generation. The first major research theme examines prompt optimization and model robustness. A groundbreaking study by Melamed and colleagues reveals how machine-generated prompts can hijack language model behavior. These optimized prompts, consisting of rare tokens and punctuation sequences, activate unusual neural pathways that differ significantly from natural language processing patterns. The findings expose critical vulnerabilities in current models, raising important questions about their susceptibility to adversarial attacks and the broader challenges of model interpretability. The second research theme focuses on efficiency breakthroughs in model architecture. Ndubuaku and collaborators introduce an innovative approach replacing traditional embedding layers with Fourier expansions and lightweight neural networks. This architectural modification achieves a remarkable 30% reduction in memory usage, while maintaining comparable accuracy to conventional methods. The efficiency gains enable deployment of sophisticated language models on edge devices with limited computational resources, opening new possibilities for mobile and low-bandwidth applications. The third research theme addresses bias mitigation in language technologies. Piot's team demonstrates how personalization features in commercial language models can unintentionally amplify geographic biases, particularly in sensitive applications like hate speech detection. Their novel debiasing technique, which penalizes inconsistent classifications across cultural contexts, reduces bias by over 15% while maintaining accuracy. This work highlights the importance of developing culturally aware systems that perform equitably across diverse populations. Evaluation frameworks represent the fourth major research theme, moving beyond traditional metrics. New assessment tools include SEval-Ex by Herserad's group, which decomposes summaries into atomic statements for more explainable scoring. Bradland's team proposes HOPE, a holistic metric for evaluating document chunking in retrieval-augmented generation systems. Meanwhile, Yin and colleagues integrate eye-tracking data with cognitive theory to create multimodal assessment frameworks that better align with human judgment. Key findings across these studies reveal several critical insights shaping the field. Melamed's work demonstrates how optimized prompts can exploit model vulnerabilities through unusual activation patterns. Ndubuaku's research proves significant efficiency gains are possible without performance loss through innovative architectural changes. Piot's findings emphasize that effective debiasing requires explicit cultural context awareness. Additionally, hybrid methods combining different technical approaches show promise for boosting both performance and interpretability. Several innovative methodologies stand out in this research collection. Dong's team combines neural networks with symbolic program synthesis to optimize tensor programs across hardware platforms. Tian's group applies direct preference optimization to enhance reasoning capabilities without costly online tuning. The successful integration of Fourier transforms in embedding layers represents another technical breakthrough. Multimodal evaluation frameworks that incorporate physiological data like eye tracking are emerging as powerful assessment tools. The first seminal paper by Melamed and colleagues investigates the hidden power of optimized prompts. Their research reveals how machine-generated prompts activate sparse neural pathways that bypass typical reasoning circuits. This discovery has significant security implications, exposing potential vulnerabilities to adversarial attacks. The findings challenge fundamental assumptions about how language models process inputs and highlight the need for improved interpretability tools and robustness checks in deployed systems. Ndubuaku's revolutionary work on Fourier-based embeddings presents a paradigm shift in model architecture. By replacing memory-intensive lookup tables with mathematical transformations, the team achieves substantial memory savings while maintaining model accuracy. The 30% reduction in memory requirements has immediate practical applications, particularly for deploying advanced language models in resource-constrained environments like mobile devices and edge computing scenarios. Piot's important research tackles geographic bias in hate speech detection systems. The study demonstrates how personalization features, while intended to improve relevance, can inadvertently reinforce harmful biases. The team's novel debiasing technique introduces cultural context awareness during model training, resulting in fairer outcomes across different regions. Crucially, the method maintains detection accuracy while improving consistency, showing that fairness and performance need not be competing objectives. Looking ahead, the field faces several important challenges and opportunities. Scaling debiasing techniques across hundreds of languages remains a significant hurdle. Hybrid approaches combining neural and symbolic methods show promise for balancing automation with correctness guarantees. Developing defenses against increasingly sophisticated adversarial attacks will be crucial. Multimodal evaluation frameworks that incorporate diverse assessment dimensions are likely to play a growing role in measuring real-world system performance. 3 key takeaways emerge from today's research synthesis. First, architectural innovations like Fourier-based embeddings demonstrate that efficiency gains can enable broader deployment of advanced language technologies. Second, fairness must be deliberately designed into systems through techniques like cultural context awareness. Third, understanding model vulnerabilities, whether to adversarial prompts or inconsistent reasoning, is essential for building trustworthy AI systems that can be safely deployed in real-world applications. This presentation was created through a rigorous research synthesis process using advanced AI systems. Content was compiled using GPT DeepSeek models, with narration optimized for TTS delivery via Deepgram. Visual concepts were generated with Grok's AI capabilities. All material was reviewed by human experts to ensure accuracy, and the narrative was carefully structured to optimize knowledge transfer and comprehension.